We're back with another problem. This one involves finding the measures of arcs as well as the central angles. Let's go ahead and start off, and let's go ahead and see if we remember what a central angle is. A central angle is any angle that you can make that has its vertex at the center of the circle. So this would be considered a central angle. Now, there's many central angles in this problem, but what we're going to try to do is we're going to try to find the measure of either every single central angle or every single arc. A couple things you need to remember: since a circle, the sum of all the angles in the circle, interior angle I should say, is 360, then the measure of all the arcs should be 360. So that means if we take this arc, add it to this arc, add it to that arc, and so on and so forth until we're done, we should have a measure of 360 degrees. One more thing you should know is that if you are given a central angle, for example, this is 55, if the central angle is 55, then the arc that angle opens up to also has a measure of 55. So in other words, whatever the central angle's measure is, the arc has the exact same measure, as long as it's a central angle. So with that being said, I want to go ahead and fill in as much information as possible right now. This is 55 degrees, the central angle. So this arc must also be 55 degrees. It looks like this angle over here is 90 degrees, but I want you to pay attention to something very close. If I take a look at that chord and this chord, we have vertical angles. So if this is 55, this should also be 55 degrees, which means this arc is 55 degrees. So far we have two arcs. And again, we know that this whole arc right here is 90. They told us that that was given. So if this is 90, one of these is 55. Simple subtraction should tell us what the other one is, and that should be 45. Excuse me, 35. So if this angle is 35, angle B to the center to C, that means this arc should also be 35 degrees. And we also know that a diameter, since this goes to the center, this line here goes to the center as a diameter, we also know a diameter should give us 180 degrees. So if this is 90 already, we know this should also be 90. Now, the last thing I'm going to use is something that's called arc addition. If you add up all the arcs in your circle, you should have, again, 360 degrees. So if I already know that arc AB is 55, arc BC is 35, arc CD is 90, let's go ahead and add that in, we haven't written it, arc DE is 55, we can add all of these angles up together, all the measures of these arcs together, subtract it from 360, add up all those arcs, subtract it from 360, and we'll arrive at our last arc, AE, which should be this angle here. Another way of doing that, a much easier way, is never forgetting that, remember, a diameter gives you half of a circle. Half of a circle is 180 degrees. So if you know that this is already 55, which we first found out earlier, if we use supplementary angles, I know that something plus 55 should give me 180, or half a circle. So I'm going to subtract 55 from 180, and that will give me the remaining measure of the arc that I need. (125) is my central angle, degrees, which means this arc should also be 125 degrees. Now that you have every single interior angle, you have every single arc, it's easy now to answer any type of question you can be given. For example, what if I were to ask you, what if a quiz or a test were to ask you, find me the measure of, let's say, arc E going through point A and ending at C. So if they want the measure of arc starting at E, going through point A, and ending at point C, all you're going to do is add 125 plus 55 plus 35, and that will give you the measure of this arc. And that's how you find missing arcs in a circle.